Hello, everyone, and welcome back. So, yeah, we've been on a bit of a roll recently. We've been doing a lot of streaming and getting a nice bit of stuff done. So, yesterday we finished up some work on basically everything to do with immutabilities. We introduced immutable variables, but we also introduced immutable structures, so lists and objects. And I'm going to continue today with, I would assume, a slightly more simple structure. It's mostly syntax sugar. So two things I'd like to do are I'm going to change the symbol or token being used for type properties. So at the moment we use the arrow symbol, kind of like in C++. I'm going to replace that with the double colon because I'm going to use the arrow symbol for the pipe operator instead. This would be similar to the pipe operator, or essentially the same as the pipe operator in a bunch of functional languages. Like I believe it's used in maybe OCaml, F sharp or F star, no F sharp. I think Elixir uses it, maybe Elm. Now, the two things I'm going to change about it, which in general I prefer to follow kind of standard practices. Well, I don't prefer it, but I think there's a lot of benefit in using just the symbols and terminology that are currently out there because it eases adoption, reduces confusion. In general, I would say the two reasons I'm somewhat unfortunately though going to change the symbol and name of this operator for this language, and the reasons for that are, one is kind of a vanity thing. This is the operator that's usually used. I just don't like the look of it. I just don't think it looks nice, whereas I think that just looks a bit nicer, and I think even when you shorten it, it looks a bit nicer. So I'm going to be changing the symbols used for the token. And then I'm also going to change the name from pipe to chain. So it's going to be the chain operator. And the main reason for that, that's less of a vanity thing, but actually more an overloading thing. So because this is a scripting language aiming to be an alternative to Bash, pipe is already going to be used for mainly a piping operation between programs. So we don't want to clutter the grammar of the language with a word that means different things in different contexts and possibly raises confusion around that. So just to keep things clear and distinct, we're going to call this the chain operator. So to begin with, we already use these symbols for something else. So we're going to want to go ahead and replace that. And so that is the first piece. And then we're going to do the same in the going to do the same in the Lexer. So let's see. And that will probably be all we'll actually need for the language itself. But now we're going to have to find all the instances of those in tests. Oh, can we do this? Oh, nice. So we have something that we need to change in main as well. That should be enough. Oh. An example of type props isn't in our features file. Do we have it in our features documentation? Where will I put that? Those, so I'll add some documentation for that. I'll put it towards the end. And I'll just borrow some function from the built-in type functions test file. Maybe I'll just do print ABC length. And what tests are failing with the changes. So runtime errors. Type method, interesting. So I think in general, I'm calling these type functions in this language. And then type functions. It's funny that I've separated built-in type functions from type functions, because I think in this language there are only built-in type functions. It is a thing that isn't exposed to user space essentially, but that is the reason for the chain operator. It's to essentially allow for custom methods on types, effectively, in a way. So built-in type functions. So maybe I just remove that file. And that will probably cause the test to fail. So I'll just start that again. And we'll go bump the version as well. What were those? So that's to do with, I think maybe cargo needs to do a cargo clean, which I'm not eager to do because that would take a long time to recompile all the intermediate files. Okay, it cleaned itself up. That's nice. So we don't need to do a massive rebuild. Cool, that's a nice tidy little change. So now we can move on to the chain operator. So let's go ahead and bump the version again. We'll add the lexing tokens and everything for that. And that will basically be what we want. Now, how this is going to work is, I guess it's going to operate, yeah, essentially like a regular prop access. Do I call it prop or do I... Well, it's less like a prop and more like a call. Yeah, so instead of it going down there, well, so we're going to do a chain, which is going to be a basic combination of a prop access and a call. So let's consider what exactly it needs to look like. So it will have to look like AF, something like that. That on its own is invalid. So yeah, so we're, and something like this where n is a variable that needs to be evaluated to a function name or to a function or something like that, yeah, is going to be invalid too. Well, the only thing is, if we have a module or something or an object, we will want a level of indirectability here. So we're going to want to say, for example, strings replace. So we could have ABC replace B with C, or strings join something like that. So we do actually need to be able to dereference the function on the right hand side. So how do we structure this? So we need to have an expression on the right hand side and the left hand side, and the expression on the right hand side is going to have to evaluate to a function. So we could have something like this. And we do it like that. And that requires that the expression be succeeded by a list of arguments. And essentially all that's going to be happening here is the first argument is going to be, and in fact, we can kind of cheat here and say that this is just a call where this expression is the first expression in the arg list. So let's see. List item. So arg list returns a vector of list items. What's the definition for list item? So it's an expression, and it says whether it's spread or not. So all we really need to do is put the first expression to the start of the args list, or the args vector rather, and say that is spread is false. And that's about it then. So what's our best way of prepending a value onto a vector? Let's see if any of these will give an idea for that. No, maybe we'll go to the web. Now we could probably just ask ChatGPT, but I kind of like just browsing the docs sometimes. Now I'm not sure. I guess vectors in Rust are good for growing in one direction, but prepending to the start isn't really straightforward. Okay, we'll just go to ChatGPT. Let's see. Okay, yeah, that works for me if it exists. So it does mean we'll need to create a block here. So now the only thing is expression precedence 5 is going to return a raw expression, so we need to pair that, oh yeah, with the location. And arguments are made of list items. So we'll have expression is that, and then is spread is false. Now, we could be messing up a bit here because we have a location for this argument, but this could be on another line. So using the same location could result in error messages that aren't so clear. So realistically, we should split this onto a number of lines. We'll just leave it for the moment, I think. Oh, I don't like that. Oh, I guess because I tried putting that in as well. Alright, forget. I put that in while I was messing around, but didn't take it out again. Oh, yeah, that's going to be somewhat ambiguous with the existing call function. Maybe what I can do is parse the rest of this and verify that it's a call, and then once I've verified that it's a call, I can simplify the call expression. So just to double check, expression evaluates to expression. A little confusing, but we might be able to do it like this. Or maybe I just do this to prove the concept first and verify that hopefully it won't cause a conflict. No, it still does. And these errors are just too verbose at this point to actually understand them fully. I think. Well, let's give a look. So when in this state, that, and looking at token this, we can reduce to an operation, but we can also shift. How do we get beyond that? Now, one option is to handle. No, actually, I was going to say that we handle the parse error at essentially evaluation time, but that doesn't get us beyond this parsing issue. Let's see what other production items we have. So at precedence 1, we have the most loosely binding expressions. So one noteworthy piece is the fact that for any of these accesses, the dereference is being done on a specific name. And in these other accesses where we have expressions, we also have delimiters at the beginning and end, so they help us reduce ambiguity in the grammar. This is quite tricky. I wonder if we can reduce the problem space by hiding a bunch of these productions. Let me try that. Okay, conflict detected when in this state where we have what? When we're looking at arg list followed by an identifier. I don't really know how to interpret these states. Usually they also had a diagram earlier in the error message that would also help to understand the whole thing. Maybe I can hide a bunch of those as well. Okay, I saw a diagram earlier, but there's still too many. Maybe I do this head 200. Oops. Okay, so let's see, maybe this helps make a bit more sense of things. So the following symbols can be reduced in two ways. They could be reduced like so, or they could be reduced by like so. So we have a arrow symbol like that. And this, okay, so the piece before the argument list could be evaluated to an expression, or the piece with the argument list. Okay, yeah, that is valid and that does make sense. So how do we move beyond that? So we would either need to specify that this expression can't contain these brackets, or can contain, although I'm not specifying. Following symbols can be reduced in two ways. Okay. So I would need to do something of the form that we do with the expression tiers, where we essentially manually unroll. But I thought that's what expression precedence 5 was for. maybe that has to be expression precedence 1. What does arglist look like? Items reverse arglist, and that uses expressions. Wonder why that's okay. So let's see. How do I make this non-ambiguous? I guess I look at expression tier. And so on the left hand side of that, we have expression operator 2 and expression precedence 3. So we have next tier on the right hand side. So this would need to be something like can I do that? Does that resolve things for me? No. Yeah, we have the same issue because expression precedence is at the same level. But then if call was on its own expression level, either higher or lower, then it could resolve things, perhaps. Now, what layer to put it on, I'm not sure. Maybe I guess call would need to go into level 6. Let's try that. No, because I didn't actually change that. Okay, let's see what the issue is here. At that point, if the next token is bracket, then the parser can proceed in 2 different ways. It can either parse all of this as precedence 6. Alternatively, the parser could execute the production at 229. Which would consume the top token from the stack and produce that. I'm not fully sure I follow, but maybe we'll try. Oh. Is that the issue? Maybe. I'm not sure why those errors are happening. I'm not sure why those errors are happening because... Oh, it's just that the files aren't being defined, and so then... Yeah, I think I get it now. Expected item, that's just to do with... Oh, because I have some debugging code. Oh. That was dumb. So let's see, dash greater than, is that in mod as well? It should be in main, I guess. Dash greater than, we'll do that. And then in AST, we can remove that. Because in theory, we shouldn't need to actually change, like implement anything. Yeah, I had a feeling we're going to run into some issues with the binding level, or with the precedence level rather. Can I... So I should be able to comment these out without much difficulty. with the parser anyway. We'll get a bunch of test failures, but I just want to check the precedence ordering. Like, can we swap these around? So let's see. Oh, we're getting a lot of errors here. Interesting that all of the errors, though, are being visually represented, that we're not just getting the symbol dump that we were before. But still, there's a lot of info there, so we'll go back to doing the head approach as well. So let's see. The kind of simplest ones are closer to the top as well. Local ambiguity detected. Problem arises after having observed following symbols. At that point, if the next token is a open parentheses, then the parser can proceed in two different ways. So parser could execute this or question mark that. I feel like that would exist regardless, no? Oh, is it because I'm, whoops, not doing this? So we're going into expression precedence 5 there, and then 6, and then 6 or 5. So it's greater at the start and smaller on the right. Do I have any other examples of this? So it's greater on the right hand side there. Can I do that maybe? No, same issue. Oof, how do I make this unambiguous? I always find this so challenging. So in general, what have I done before to make these things less ambiguous? Well, in fact, maybe I go through it on paper to sketch out what it should look like in terms of if we were to get one of these ambiguous phrases or strings, then in what order should, like, what should the AST look like afterwards? So let's see. So let's bring this up here. And let's see, I'll have to add a new window to OBS. I actually haven't shared my screen here in a little while, so let's try this. Oops, that is filling the whole screen. Usually I wouldn't edit live like this, but it should be okay. There we go. Cool. So, in fact, can I shrink this screen a little bit so that we can see our code a little bit at the same time? So, what have we got here? We have, for example, my var. That isn't showing up very big, is it? So let's zoom in a little bit on that, because we don't need a ton of screen space, I think. So we have my var, or let's try, shall we say, my string, and we want to allow something like strings replace. Actually, maybe we will zoom out just a little bit. And we'll say replace A with B. Now, the trickiness here is that we want to be able to support that, but that can be parsed in a number of ways, because we can associate, we can say that this is a full expression, and we apply the call to all of this, which is what we want. But it's also possible to say my string replace A, B, and say that this gets applied as a function call first, and then we do this kind of a dereference. So I think what we're kind of saying here is that this section has to be, or rather, this section has to be the most loosely binding. So it can appear after a long expression, and it's going to be the last thing that gets applied. But that's in a way not really what we want all the time, because if we have a function that returns a function, if this is the most loosely binding, then, well, maybe that's okay. This gets bound first, and then this gets bound. So that becomes our AST, which is what we want. This is all quite tricky. And we've moved the call precedence up here. Like we've made it more loosely binding. But that's given us an issue. Well, the issue isn't really with the call here. It's rather with the recursive nature of this. And we could probably get rid of that recursion issue with this, but then that creates its own ambiguity. Does it? I don't think it does, actually, if anything. Yeah, it does, because we could have parentheses in here as well. Let's try that. That's okay, we'll just... Right, like that. So we at least don't have a conflict right now. And this makes sense. So we're kind of skipping... We're saying expression precedence 6, so we're skipping all the conditional operation, all the comparisons and arithmetic expression types. We're still allowing dereferences and things like that. Can I mean, I'm fairly sure I tried this before, but just thinking about it a bit more, it feels like it should be possible. So it can be reduced as... That is expression precedence 5, and then 2 6s. Or like that. So if we have that, it could be an expression precedence 6 or 5. So that seems to be I'm kind of just mucking about here at this point. Yeah, I think this approach is probably the least ambiguous. And it should allow for recursion here. And these all need to be changed to level 6. At least the one positive or potentially positive thing here is that if we're able to get it building and passing tests, then it should mean that that is all the implementation that's actually needed. So let's give that a go. And we do want this as well. So we do want it at the lower numbered precedence level because we want it to be more loosely binding. So now let's try rebuilding everything with all the features enabled. And then we can try adding some tests for this. And I guess since we're splitting this onto multiple lines now as well, we can say arg location and func location. And it also makes me think arguments should probably keep their location as well. So we have an expression here, but expressions like raw expressions don't have, or an expression is a raw expression with a location. Okay, and when we captured the expression here, it actually does keep the location information as well. So that's actually fine. So now let's try out this feature. I'm actually not so sure how it's going to I'm actually not sure how well it's all going to work, because I mean, it was a little bit of programming by coincidence. Like I was able to reason out some of it, but it's still unclear to me exactly how all the AST parsing is going to look in practice. So let's just give it a go. We need to add to the features file first anyway. So let's try this. So we'll have a function trim, or we'll have add A and B, which will return A plus B. And that should be how we do it. That feels very strange. It feels like we got something for free there. Oh, yeah. I was like, in a way, I was like, oh, yes, an error. That means we have something to work with. It doesn't handle all cases, but actually, that's, yeah, it looks like it's working as intended. So let's see. So now we're going to try something a little more complicated, which will be to do a property access as the function. I'm not sure if that's going to work. We'll see. So let's have a simple function indent. then R. And we'll have a function here as well, just increment, that just takes a value and adds 1. So we test the case where we take 0 arguments. And then we'll have, well, we'll just call it prefix. And so down here we want to do strings prefix. Let's try all of these. Okay, we've got an error. Interesting. So it looks like it is the AST is possibly being formed like this. So we have Joe strings prefix hi. Actually, I'm not sure how this is working, because this should be a call. There shouldn't be ambiguity here. And then this is being handled as an expression precedence 6. Let's see what's going on here. Oops, what happened to my note? So I'll go back into the parser. Expression precedence 6. And we've got a dot here. So we should be getting am I just misreading? No. Oh. Not used to my own language. Okay, nice one. Yeah, so we just kind of got that feature for free in a way. Just by implementing, like, yeah, it really is just syntax sugar. So I've got this decisions file that documents design decisions. And so I'm going to add in a blurb on this, on the design decisions made for the chain operator in a second as well. So I've got type functions, parameter destructuring. Where will we put the chain operator? I guess we'll put it under functions actually. Well, this is all in the functions section, so. So what's the utility of this? So I'm just thinking, could you use it to perform binding for functions? And yes, and essentially achieve currying, and you could, but realistically, I don't think that's terribly useful. I mean, it's nice, like it's a nice and flexible concept, but in terms of actually return on investment, like I think if you're going to be binding variables, it's often easier just to create a new anonymous function. And in terms of how often that would then get used, like as a language feature, I think that it's not really necessary here. And in fact, I must actually demonstrate the chaining mechanism. and double check that it actually works as expected. Nice, and that passed as well. Well, good boy. So, whoops. Not sure what happened there. And so this allows for pipeline or chain or fluent-style for whoops. For successive function calls. And that's probably all we need to say about that. And we've got our tests all in place, but we do want to add our decisions document now as well. So for this one, did I put anything in here? No. So we've got firstly chain operator. We'll be handling processes and Cool, and that's about that. Are those in the right order now? Did I put the precedence levels in the correct order again? Yeah, precedence level 5 is at the right position. And so we'll commit that. Do we have anything we need or want to add to the README at this point? I do want to add more details on the features of the language in the Hello World blurb. But I think that is okay for the moment. So we've implemented all of that. And again, that's probably a good place to leave it for now. But I'm really interested in doing some work on the error handling, because I've got some ideas now on how that is going to work and how it's going to look. So I have a bunch of notes here, but in summary, we're going to say that we throw errors using this kind of a syntax. So we start off with, let's see, the error name, which will just be a string. Or we'll start off with the detail. Okay, so throw. It'll take an object, and the object needs to have a name, which is a string. And that's it. Do we want to call it name or code? Actually, code might be more relevant, because it has to be, like, the linter will suggest that it has to be conforming to conventions, but it should be a name with, in snake case. And so that's the basic, but it can also have, as long as it has that, it can also have a reference to a function, and it can have a reference to, or it can contain more objects inside it. Now, these aren't going to be validated as precisely as code and function, because it could be a large tree and we want to minimize our overheads. But we're going to have a syntax sugar for these. So for example, if we have my error and we do this, it'll throw my error, and code and function will automatically be populated. Code will be populated with my error, and function will be populated as with a reference to the current function. And then if we also add some context as fields here, then those will be added to the object here. Now code function and inner will be reserved keys, so added fields cannot contain those. And finally, we can also add extra, what are they called? Context, or the inner values or the inner exceptions for rethrows can be put in there. And those will just be validated to verify that they're objects, but they won't be recursively checked or anything like that. So that will be for throwing, and then we'll have this, well, even with that mechanism, we already have a mechanism for catching those kind of errors with the OK version. So we'll have a value and an OK, but in this case, we'll have a value and an error when we catch like this. And we'll be allowed to, we'll have a new operator as well, which will perform an error check, and using the same kind of construction as we have up here, we can say, does it match my error? Does it match my error which came from this function? Does it match? And basically that's all we're going to have. I was thinking about allowing so this will be kind of a recursive check. And I was thinking we could match the error that matches it, or like capture the error that matches the field that we're talking about here. I'm still not 100% on that, but I don't think we probably need it. Well, we probably do actually. Even though I don't love this syntax, but I'm also not sure what other syntax we can use. So it's generally going to be in the context of an if statement. Yeah, I really don't know. But at least this much, I think, is what I'm interested in. And we can, start implementing that soon enough. I mean, I'd love to dive into it now, but I think that it's probably a good idea to pause for the moment. And take a little bit of a break at least. But it's been good progress today. The chain operator ended up being much more complicated than I thought, but also easier in other ways, because once we implemented it, the AST part of it, that was basically it. There was no further like implementation needed on the evaluation side of things. So that was pretty cool. And we renamed the type property symbol as well. So all in all, pretty good progress so far today. We'll see if I come back after a quick break. I might do that. And yeah, I think that's a good place to park it for the moment. So as always, thanks to everyone who checks out these streams and these videos. Interact with them as much as you can. So liking, subscribing, all that good stuff. And yeah, thanks very much for checking this out, and I'll see you again. Bye.